Hi there, folks. Today we're looking at measures of central tendency and dispersion. And the measures of central tendency, these are the ones that we've done for about 1,000,000 years now. Mean, median, and mode, okay? Remember, the mean is the average. It's when we add them all up and then divide by how many we have. The median is the middle value. That's when we have to put them all in order and then find the one in the middle. And then the mode is the one that appears the most often, okay? So these are used for kind of summarizing data when we talk about measures of central tendency. So again, mean, add them all together and divide by how many we have. It's the average. The median I think to me is the most tedious of all of these because we have to rearrange them, put them in order first, and then start working our way to the value that's in the middle. And remember, if there's a tie for what's in the middle, you have to take the average of those middle two. So you take the mean of those two values. So if there's a tie for the middle, so if there's a tie, we find the average of those two, or find the mean, okay? So just remember that, that little nugget. For the mode is an interesting one also because we have to remember that there can be more than one mode. So if there's a tie, we have more than one mode. But in order to be eligible for the mode, it has to at least repeat more than once. So if there's only one of every value, then there is no mode. So that's like an extra little piece attached to that. So if there's no repeats, then there's no mode. Okay, so there's a couple little stipulations that we have to worry about with some of these. Again, median, if there's a tie for the middle, we find the average, and that's our median. The mode, if there's no repeats, then there is no mode. But if there's a tie for the one that repeats the most, then there's more than one mode, okay? And in terms of which of these we tend to use when summarizing data, the mean is like the default in terms of being the best, okay? So I'm going to say default best. So if it says, what's the best measure of central tendency, we default to the mean, all right? The time that we won't use the mean, the time that the median will be the best, this one is the best when there is an outlier. And we're about to talk about those in a moment. Okay? And then the mode, we almost never pick the mode as the one that's the best, unless for some reason almost all of our values are the same. But in that scenario, the median would work out as the middle value anyway. All right. So the mean is by default the best value for measure of central tendency, the best measure. But the median gets used when we have an outlier. Okay. And if you recall, outliers are these values that are much greater than the rest of the data values or much smaller than the rest of the data values. They're so far to one extreme that they almost don't count and shouldn't count, all right? They're way too big or way too small compared to everything else. They're kind of a special case that happened within whatever scenario we're discussing, okay? For example, if I look at these guys, I want to find the mean, median, and mode. I have 8 bowlers and their scores here. And the first thing I might do, like if we're just finding the mean, I would just start adding these together and dividing by how many I have, all right? But since I know I need to do mean, median, and mode, the first thing I like to do is get organized by writing these down in order. So I've got a 104 is the smallest, and it looks like I have another one of those and another one of those. And an easy way to stay organized is just put little marks next to each of these as you get them. See, I'm putting little check marks there, put little dots, or do whatever you need to do to kind of mark. What I wouldn't do is I wouldn't cross them out in case for some reason I need to still read that value. So it looks like I get a 109 next. And then after the 109, looks like the 113. And then the 117. And then the 136. And then that 189. Okay, but make sure you're just keeping a tally of, okay, what have I written down so far? And another nice little check that you can do at the end is you can just count up how many data values you have written down just to make sure it at least matches the total number of data values that you had, all right? And so now from here, I want to find the mean, median, and mode. So the mean, I'll find that one first. You'll also see the mean abbreviated this way as an X with a little bar over it. That also indicates the mean. And in order to do the mean, I'm just going to pull up my calculator here, and I start adding these up. So 104. And most of the work that we do here is done on the calculator. Okay, so that's the addition, and now I have to divide that by how many I have, which was 8. So I get a 122. And notice how I plugged that into the calculator. If you want to try to punch it all in one shot, that stuff divided by the 8, you have to put all that addition in parentheses, or it's only going to divide the last value, okay? So I like to punch in the addition, hit enter, and then divide it by the 8, all right? So that's the mean. The median we start marking off from each end. And then once again, I am not going to cross these out. Maybe I'll underline them, put little dots. So there's the two ends. So it's like I'm crossing those out. But again, I don't cross them out just because I want to still be able to read them. And then I take another one off of each end. And when it's all said and done, I get down to these two values kind of tied for the middle. So these guys are tied for the middle. So what I do is I find the average of those two. So I do the 109 plus the 113 and divide by 2. And here's the thing, you could get away with not actually doing this work. The average of just two values is whatever's halfway in between. And you might be able to look at 109 and 113 and say, okay, the number that's halfway in between those two is a 111. Well, that's what the calculator is about to give me. If I do the 109 plus the 113, again, I hit enter and then divided by the 2, I get 111. So that's my median. So I've got the mean, I've got the median. The last thing I need to do is find the mode. It looks like I have a 104 that repeats 3 times. No other value comes close. So the mode this time is the 104 because that value repeats the most often. And that's it. So mean, median, and mode. All right. The follow-up question to this is which measure of central tendency is the best for this data set? And again, by default, we typically go to the mean unless there's an outlier. So I have to look at this data and say, okay, are any of these data values much bigger or much smaller than all the rest? And hopefully you look at this and say, well, yeah, this guy right here, not even close, right? That 189 is much bigger than the rest, okay? So when I think about that 189, I would consider that an outlier, which means the best measure for central tendency this time is the median. And it's a median because an outlier exists, all right? If you were to find the average, if you were to find the mean without that 189, it'd be a lot closer to the 111. That's what the median does. Because when you think about how we found the median, we cut off the values starting on the outside, so we cut off those extreme values, okay? So we're going to go with the median this time because there's an outlier. Okay. All right, so in this example, it says your grades on 3 exams are 80, 93, and 91. What grade do you need on the next exam to have an average of 90 on the 4 exams? And so basically the situation is this. We're trying to find the mean or the average here, and we have 4 exams total that we're talking about. We have the 80, the 93, the 91, and then one that's yet to be determined, so I'm going to call it X. And those are the 4 exams that I want to find the average of. So I have to kind of take the definition of the mean literally here and say, okay, the average is when I add all these together, even though one of them I don't know, and then divide by how many I have, even though, again, one of them I don't know, there's still 4 exams here. And when that's all said and done, I want the average to equal a 90%. And so now from here, it's just a matter of simplifying this thing. So it looks like I get a 264 plus x over 4 equals the 90. And now this is just a linear equation that I'm going to solve, so I'm not real happy with that division sign. But if I was solving this linear equation, remember it's implied that there's parentheses around this, so I have to undo the division first, so I multiply each side by 4. You could also put that 90 over 1 and cross multiply, but here the 4's cancel, so I'm left with the 264 plus x, and that equals a 360. And now I'm going to subtract that 264 from each side. So I find out that x equals, looks like a 96 over here. So in other words, in order to get the correct average, I need a 96% on that final test, on that fourth exam, all right? And you can very easily check this thing by plugging it back in. So if we want to, we can check it on a calculator. Let's find the average of those exams. I do an 80 plus 93 plus 91 plus the 96, and I divide by how many I have, which is the 4, and it does indeed give me that 90%. So again, we're just kind of working through this thing with the variable in it. It results in a linear equation, okay? If we talk about measures of dispersion, the only one we're going to look at here is the range. And the range is the difference between the highest and lowest data values. We're essentially looking at how many data values are covered, all right? And so if we look at these, this last example here, it says the closing price of 2 stocks for the first 5 days in February are shown. What is the range and mean of each data set? So I'm going to start by finding the mean. And again, you can just say mean, or if you want to abbreviate it with the X with the bar over it, that would also be fine. So I'm just going to add them all up and divide by how many I have. I'm going to do this right on the calculator. And it looks like I have 5 data values. So that one has an average of 32, so that's the mean. Over here, doing the same thing with the next one. Well, I have my calculator pulled up. So I've got the 34 plus the 28, 31. And again, divide by how many I have, which is the 5. So I get an average also of 32. And so each of these has the same average, but now I want to compare the range of the two as well. So let's look at the range of each. The range is just the biggest data value minus the smallest data value. And so in this example, the biggest data value is the 47. And it looks like the smallest data value is the 25. So when I do the 47 minus the 25, it gives me a 22. The next one, again, if I'm looking at the range, it's the biggest data value minus the smallest data value. So in this one, it looks like the biggest data value is the 36, and the smallest data value is the 28. And if I subtract those, I get a range of 8. All right? And see, this is very telling for us, because if I'm looking at this, especially in terms of something like a stock, the average of each of these is the same, but the range of the first one is a lot higher than the second one. Okay? And what that means is that the second, stock B, is a little bit more consistent when it's all said and done. All right. So if we're talking about something like stocks that we're planning on investing in, that first stock varies a lot more. It's up and down. So the extremes of how low and how high it goes are a lot greater than the second one. So the second one is maybe a safer type of stock in terms of its consistency. All right. So they each have the same average, but stock A is a lot less consistent than stock B. All right. And that's kind of what the range tells us. It's telling us how far spread out this stuff is in terms of the smallest value and the biggest value. Okay. The next measures of dispersion we're going to talk about are the variance and standard deviation. And kind of like the range, they're measuring how far spread out this data is. The difference here is the range kind of measures how spread it is based on the highest and the lowest from one extreme to the other. The standard deviation, and that's really the one we're going to focus on here, the standard deviation kind of measures how spread it out it is kind of from the middle of the data, from the mean actually of the data. Okay, and so it's measuring kind of a similar type of thing. It's measuring how spread out we are, all right, but it's measuring it from a different location. It's kind of measuring it from the inside out rather than from one end to the other, okay? Kind of measuring from the center out, using the mean as kind of that center value, all right? When we talk about the variance standard deviation, notice these are the same formula. The formulas are literally identical. The variance is basically a stepping stone towards the standard deviation. It's the same formula, but we take the square root of the thing. And really, the standard deviation is the one that gets used. The formulas that I have here, these are for when you're looking for variance and standard deviation of a sample rather than the total population. And so when you're talking about the population, the variance and standard deviation for the population, the difference in the formula is that it's just an n down here instead of an n minus 1. Most of the time, you're going to use this sample formula, so that's the one we'll kind of use here. But we'll see both of them when we start to plug these things into the calculator, all right? When you look at this formula, just kind of scrolling down here, the x of the bar, we already know that is the mean. That's the symbol used for the mean. X sub n, that's each data value. So when you look at the formula here, notice it's got like x sub 1, the first data value, and then the second data value, and then the third data value, and then the next data value, and the next data value, until you get to the last data value. And that's why it's listed as x sub n. That's why we have these data. We don't know how many data values there are going to be. So really, I just do each of the data values here. And then n is the number of data values that we have. And just kind of looking at this formula in general to kind of show you what's happening here, essentially we're looking at the difference or the distance from the first data value to the mean, all right? And that's what's happening inside this first set of parentheses. In the second set of parentheses, same thing. I'm looking at the difference or the distance between the data value and the mean. And then the next data value, the distance between the data value and the mean. And then I'm squaring all those things and adding it all together. And really, it almost is like a sense of mean itself when you kind of see what's happening here in terms of adding all these together and then kind of dividing by how many we have. We're essentially kind of measuring how far everything is, each of the data values is from the mean. And then we're kind of getting a collective sense of how far we are from the mean as we kind of spread out along this thing, if you want to think of standard deviation that way, okay? We're measuring how far spread out the data is based on measuring from the center, from that mean value, okay? And as we move out, when we talk about things that are normally distributed, as we move out from the mean in increments of the standard deviation, we're going to pick up a certain percentage of our data values. We're going to start collecting those things because typically things will hover around the mean, okay? And so taking a look at this example that we've kind of already looked at once, but this time we're going to do the variance and standard deviation. And we're going to do it using the graphing calculator here. So here's how to do this on the TI graphing calculator. The first thing we're going to do is we're going to hit this little button that says stat on it. We could plug this in and do the formula by hand, but I want to show you how to do it on the calculator. Plugging into formulas is literally just that. It's just plugging away. Everyone should be able to do that. I want to show you how to use the calculator to do this. So we go to stat. The first thing we do when we get to the stat menu is we're going to hit edit. We want to edit the information that's in the calculator. And that brings us to our list here. We're just going to punch these values into list 1. If you already have a couple values in the list like this, you can go up and delete each individual value here. So like the 3, if that's highlighted, you hit delete, it'll be gone from the list, and then you can delete the next one. If you want to clear the whole list all at once, you highlight L1, do not hit the delete button, hit the clear button, and you'll see it disappear from down here. It'll disappear the rest of the way as soon as you go back down into the list, okay? If you delete the list, it'll be gone permanently, and you have to run the setup editor again. It's a whole thing. You don't want to do it. So don't delete a list. Delete individual values, but clear the list, okay? And so now let's punch all these values into list 1. And so I have all of my values punched in here. And once I have those values punched in, I'm going to go back to the stat menu. So over here, stat. I'm going to go over to calculate, and I'm going to calculate in one variable statistics. So I hit one variable statistics, and that's because we're only looking at one thing. We're looking at bowling scores, and that's it. These aren't paired up with anything else. So one variable statistics. If you have a newer TI calculator, it might ask you to confirm that you want it to look at list 1, that kind of thing. And then you might have to scroll down to the word calculate. For our purposes for this one, I just hit the enter button again, okay? And so it kind of gives me this list of information here. The very first thing you should notice is that the first thing listed is that X with the bar over it. And then x with the bar over it, well, that's our mean. That's the symbol for mean. So I'm going to copy that guy down. So let's copy down the mean. And we already calculated the mean by hand earlier, but here it is thanks to the calculator. The next thing that it looks almost like a pointy capital E with an X next to it, that is uppercase sigma. And that uppercase sigma of X, that means the sum. So these are the sum of all the X values. In other words, the sum of all the data values. The next one, that's the sum of all the data values squared. And then the next two, these two are both this S with the X and this sigma, which is that symbol we saw earlier with our formula. Those two both represent the standard deviation, okay? However, this S with the X, that's the sample standard deviation. This second one, sigma X, that is for the population, okay? So the one that we're looking at is this SX, so the 29.11. And notice I'm still going to use the little sigma symbol. It's like a 0 with a little hat on it. All right, that's the lowercase sigma. I'm still going to use that for my standard deviation. The thing that the calculator doesn't give me here, and maybe you realized it already, but it doesn't give me the variance. All right, so for this one, the variance is not given. What we have to do is we actually have to take this value, the 27, or sorry, for our purposes, the 29. So the 29.11062643. And we actually have to square it, okay? When we're doing the formulas by hand, typically we'll find the variance, and then we'll take the square root to get the standard deviation. But when we do it on the calculator will give us the standard deviation. We have to square it to get back to the variance. So 847.43. And again, I'll label that as sigma squared for this one, okay? Couple other things that are on the calculator here just to kind of show you these things. I have to go back in and get my calculated values again because it won't let me scroll down. You notice there's a little arrow here. So n is like the number of data values, but that arrow means you can keep going. There's more stuff here. Look at this. We've got the minimum, we've got the maximum, we've got the median here, and we've got the first and the third quartiles. Remember doing box and whisker plots? Well, here's all the information we need for like a box and whisker plot. Okay, even something like the range, really easy to find right here because now it kind of sorts all the values for me. And you know that might not seem beneficial, but if you have a list of data values that's pretty extensive, one of the things that really stinks about the median is writing all this in order, it's sorting all the data. Using a calculator or a computer program to do that for us works really nicely. And so when you have lots of data values, letting a calculator do the median for you is pretty fantastic. Even finding the minimum and maximum can be nice in order to find the range, okay? So again, you go to stat, edit, put your list in, then stat, calculate one variable statistics, and it will give you all of these values, okay? For our purposes, the sample standard deviation is this first one, is the S. Sigma is for population, okay?